Let's talk about problems where you have to square both sides. So if we're looking at a situation like this, you're going to say, well, sine and cosine, there's no direct relationship. You'd say, oh, well, if it was sine square is equal to cosine square, then I could do a substitution. All right. Well, there's one big problem with the squaring both sides technique. So let's think about this. And I think I've already pointed this out in a different video. If I've got x equals 1, and then I square both sides, you get x squared equals 1. Then going from here to here, then x could be plus or minus 1. Well, see, I introduced -1 as a possible solution by squaring both sides. So when you square both sides, we introduce possible extraneous solutions. So that's the one thing we got to watch out for. And I can't spell this. I think I've already said this in another video. And I can't spell extraneous. I don't know. I can't spell, whatever. Solutions. Okay. So anyway, that's the problem with squaring both sides that we got to be careful for, is we introduce possible extraneous solutions. So in a situation like this, you say, well, wait a second, they're not equal. I mean, I can't do a direct substitution because there's nothing I can do. But if I squared both sides, then you could do either one. I could substitute 1 minus cosine square here. I could substitute 1 minus sine square. So I'm just going to do the 1 minus sine square. What the heck? Doesn't matter. Now, if we add sine square to both sides, and now we can just do like we've been doing on the previous problems. Oh, so this would be the square root of 1/2. When we're solving for a variable, we got to remember to do plus or minus. And we should be real familiar with this at this point. That's good old root 2/2. So you would say, okay, easy. Sine's root 2/2. Well, that's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Yay, it's got 4 answers. But wait a second. We squared both sides. We have to check to make sure we didn't introduce any possible extraneous solutions. So you'd say, okay, pi over 4, well, that would be root 2. 3 pi over 4, this one's positive, this one's negative. Oh, got to throw that out. 5 pi over 4, they're both negative. That's okay. 7 pi over 4, this one's negative, this one's positive. Got to throw that one out. So there's actually only 2 solutions to this. Okay. All right, then you get something a little more complicated like this. And you're thinking, well, if it was tan square or secant square, I could do a substitution, but it's not. So we have to square both sides. Or I don't know, maybe we could figure another way. But this is a possibility. We could probably figure another way. Thing about this is we got to remember, parentheses squared, you've got to remember to FOIL it. You have to FOIL it out. And then for this, we're going to substitute tan square is good old secant square minus 1. So now we're going to subtract secant square from both sides. And we're going to add 1 to both sides. So now we're at 2 secant plus 2 is equal to 0. So secant x is equal to -1. Did I do that right? Whoops, I got too many x's. Secant is equal to -1. Okay, that works. So when is secant -1? Well, that only happens at pi. But I better check my work. Because I squared both sides, I need to check my work and make sure I don't have any extraneous solutions in here. So let's check this out. So secant, let me see, that's -1. Tan of pi is 0 because we love us some unit circle. So that answer checks and we're happy. So anyway, something else we got to think about. So squaring both sides.